Okay. Okay. Anyone in here? I don't think anyone is in here. Yep. I'll wait until someone gets in here. Can I like pop this out? It's in here. I how did I this? Yes. Okay. Shimoli chat. I decided to stream in the worst moment. Probably. Why? Okay, sure. Okay. Yeah, that wasn't planned. Anyways. Yeah, so we but the mic is kind of bad a bit. Okay, let's see. You can hear me breathing? Perhaps it's too loud. Let's see. Is this better? Volume was fine. Yeah, then I have no idea. Filters, perhaps. Let's see. Uh, the sensitivity. Okay, but how do you change the sensitivity? Yeah, I need suppression. Okay, good. That's okay. This better? Okay, good. Hopefully, I can be heard. I mean, I could like. Okay, good. Luckily enough, I have my speakers on, so. Should we make him? Okay, so what am I gonna do? I have this library called SCDH, which is basically a bunch of like data structures in a header-only system. Basically, the TLDR is you can use it without having to build the library, and it also supports generics at compile time, which is something you don't get that often in C. Like the way you would normally do some generics in C is you would make a, I don't know, like a, let's give an example, like a I guess vector. So you'd have like a struct that has a void pointer in it, like a size t, which is len, a size t capacity. This is just an example, okay? So you would hold a void pointer, and you might also want to hold an item size here. And the reason is because the way you would implement is this, for example, you take in the item size and like a let's the initial size, initial cap, okay. Like you do some memory allocation here, and then on something like a push function, which is supposed to add an element at the end of the vector, it normally would take in, well, the vector itself, and it should be here as well. So normally it would take the vector itself and like a void pointer, which is the item you want to add to the vector, by pointer, and then you do a memcopy basically into vecbuff this item, and you know the size because it's in vector. Okay, you do something like this. Of course, like here you have to take memory bounds into consideration, etc., etc. But this is basically the TLDR of how you would normally see an implementation of generics in C. The problem with this is that now every instance of vector needs to hold 8 extra bytes on my system. On 32-bit system it might be 4 bytes, but it's like 30% larger for no reason. And you also don't get type safety. This means that, like, now again it's C, but so I'm not sure. My microphone is blowing up. What do you mean? Okay, okay, is it still blowing up? Hopefully it isn't. Odmers. Okay. Now it's too low. Okay, let's see. Perhaps I can do this. This better? Oh, hello, my CF. I hope you don't have a LOL tournament to look at. Okay, amazing. Thanks. Alright. So, normally in C you wouldn't worry about something like type safety, but I like my type safety. So, like, the thing is, you could call VK push and pass it any pointer, and like, you could say that I have a vector here that like contains, for example, let's see, what would be an interesting type. Let's say you have a vector that contains characters. Sorry, size of car. So in VK push, you only pass in a void pointer, which is basically anything. I could have a character, okay, and let's give it, I don't know, A, and this would push I on the vector, like the way you would expect it. No, car. This is the way you would expect it to be used, but like nobody's stopping someone from doing something like this. Okay, and like the way that this is implemented, this would just copy the first, like the first byte of I, which in this case would be 0xFF, but it's not that safe, obviously. So the way I get around that is basically with a lot of hacks. The vector implementation in this library is the dynamic array, and as you can see, it's preprocessor magic. It's not that fun to work on, but like going through the edge cases that arise when you start working on it was actually quite fun, because you end up like learning how the preprocessor works along the way. And today, and this is what I was getting at, we're adding a new data structure to this bunch. Currently, we have dynamic arrays, which are basically a stack or a vector, if depending on which languages you know. We have hash maps, which are basically a dynamic addressing, open addressing implementation, specifically with linear probing, because I really don't like linked lists for something as common as a hash map. And we have a string, which is basically just a type-diff dynamic array with some extra utility functions, and a string slice, which is yoinked directly from Rust, and I don't regret anything about it. It's amazing. Like, if you see how beautiful it makes string parsing, it's gonna be so fun to use this. I've used it already for a lot of assignments, but it's really good. I actually love it quite a lot. So, and also like a bit set, which, well, I'm pretty sure most people know what a bit set is. It's an array of bits. My theme is Graphbox, yes. Both my system and my editor theme. And I also have this, which is taken directly from a homework assignment that I had, in which I used this library. And I was like, wait, I can put this into the final result. And I did. I just added this into the library, which is a JSON parser. Now, I have some to-dos in here, which are... Oh, just for error handling, okay. Yeah, they're just for error handling. That's pretty interesting. I didn't actually expect to only have an error handling to-do. But, oh well. I digress. We're making a new data structure. We're making, as much as I don't like it, a linked list. Who cares about errors, am I right? Well, it's not that it doesn't handle errors, it's that it doesn't differentiate between errors. Like, I generally prefer to report errors on all of my functions, but like, in this case, I was really just trying to finish the assignment, so I was like, I don't really care what kind of error it is, I care that it is an error, and so I need to fail, because the assignment was to implement a program that interacts with OpenAI's API, and in that case, I mean, I usually expected my JSON to be correct, so it didn't really matter. But if I got wrong JSON, it just meant that my request got interrupted or something. So I would just crash the program instantly. But anyways, let's get started. So we'll start with header guards, because of course. Pragma once is, well, technically speaking, most compilers nowadays will allow you to do Pragma once in C. Yeah, go. You can technically do Pragma once in C, but I just don't trust that it's compatible with my compilation options, because I compile with Pedantic, and in case you don't know, Pedantic is, well, really like austere in what it does. It's not an easy thing to fool. So let's start with this. So the way I usually implement this is I first implement the basic version using void star, and then I go on and make it into the generic version, because I want to implement the logic of the data structure in something that can have that I can have good error reporting on by the debugger, and that I can get compile time symbols for, instead of generics, which technically speaking, those are also compile time symbols, but they are really unpredictable in how they're gonna work. And not only that, it also is a bit of a pain to work around the preprocessor while you're trying to put logic in. So I just separate the stages into first implement the logic and then make it generic using macros. So probably today is going to be just logic day, okay? Okay, let's store a void star, which is the data. And perhaps it might be better to do something like this and then type def a list node t pointer into linked list like this. And I guess it's ll. ll sounds like a good prefix. ll init, and we take in a linked list pointer, which is the head. Now again, the way you do this for a header only library is you do something like you'd go here and go like if def linked ll impl, for example, and if, but I'm not gonna do this right now so that I can get good error reporting by Clang. What's happening? Okay, we got some people. Okay. So, well, we don't really need to do a lot. We just need to what? Yeah, perhaps a floating screen. Okay. So, oh, hello. Aris wanna VC? VC? Question mark? I'm gonna join a voice chat here. Okay, there we go. Back here then. So the only thing that we have to do here now, again, this is a double pointer, and the reason for this is because, well, you don't really need anything else. A double pointer is enough. And so the only reason that I return int is to stay compliant with the norm I've set in the other parts of the library. I'm not gonna do that. I'm not gonna have any errors here because really all I'm doing is setting this pointer to null. I can go head null. There we go. Okay. And I'm gonna need std def, I think, has null. Yep. Okay. Now, we also need a dinit method, which is gonna take a linked list, but I'm gonna leave its implementation currently for reasons you will see later, because currently we don't have a view of what the list will look like, and we're gonna get that by adding the push function here. And let's take in a size t. Okay. The reason I'm doing this is very like bare bones. It's just I'm bored to store a field and then have to remove the field instead of having it. Actually, it might make sense to. Yeah, no, but then I'll have to expand linked list to extract, and I don't feel like doing that. So now, this is a function that can fail, and the idea of how we implement this is the following. We want to implement a chain of nodes, okay, that ends in no. Usually we denote no with this little dot. You don't really have to do that, but anyways. So push is supposed to be the fast version of adding items to the list. And if you think about this structure here, the fastest way to add a new element is create a new box and have it show the old first box, okay? And put your data in here, but that's not really that bad. Okay. So the way you do this is, firstly, when you push an element, you always have to create a new node, which means this function can fail. And for those of you who think that you don't have to check memory allocations, you're just wrong. Memory can fail to be allocated. Not all systems run on a kernel. The bare bones exists, so my bad. Like embedded exists, so you can't really trust that you'll always have an allocator that will give you a valid page even if you don't have the available memory. So the way you do that is you just create a new list, a new node, my bad, a new list node, which is going to be on the heap, okay? And I use calloc here. You don't have to use calloc. I just like calloc because it also like exits some cases where, wait, so this is size of list node, because it handles the case where this multiplication can overflow. List node pointer. Yeah, this is just a complaint because of header files which are considered C++ by ClangD. Okay, void pointer, but list node, there we go. So if we fail to allocate the node, we return an error, and it's the user's responsibility to handle that error. Now, if the node was created, it means we have a new box, so what we need to do is copy our data into the box. Okay, this is our data. This is our new item, basically. You copy it into the box, okay? And then you connect the box to the old first box, which in this case is going to be basically setting next to where head is. L. I'm gonna name this head to make sense. Now, to copy the data, I guess we'll have to create a memory block of item size, and this is this. No, this is item buffer, and then memcopy into that block item and this many bytes. And of course you need to check for failure here. And if this fails, remember we need to free the old node, the new node, because it means we exited early. Okay, so now we've copied the data in there, and the last thing we need to do is, well, let's move this down here. The last thing we need to do is change the first node, the node we consider to be the first node. Specifically, head is currently showing this node over here. We need to make it show this node instead, which is basically as easy as just head is new node, like this. Oh god. And just return 1, which means everything happened successfully, like this. So this is how you add an item to the beginning of the list. Any problems with microphone or anything? Hopefully not. Okay, my bitrate is good, so I guess that's that. Okay. Back to this. So now we need to test this somehow, and well, I've made a system here which just allows me to test it. So let's just directly do the stuff here and go linked list L. You need to include linked list, and we get this stupidity, which I don't really like, but it's just clunky being an idiot. There we go. Okay. Well, I know that LL init cannot fail, so I'll just call it directly. Don't do this in other parts of the library. It's gonna fail hard on you, and you don't want to see that. Alright. Now then. Let's push an element into this. Into L, we push, I don't know, int I 0. We push I size of int. Okay, and we need to assert that this is good. There we go. Now I need to change my makefile, and we are ready. Linked list tests. It should be in plural. There we go. Okay, and we get an undefined reference, which, well, it makes sense. So let's now start making the header only thing. Okay, we need to declare this functions unconditionally in this header. Oh, actually, yeah, it's just the init that had a problem, which means this is just because this does not have an implementation. So let's look what the implementation of the init is gonna be. So say we have a list like this, and we wanna basically deallocate all the memory that is taken up by the nodes and by the copies of data we're storing on every node. The way you would do that is basically you'd start at the first node, okay? You would free this, then you go to the next node, you'd free this, etc., etc., until you reach null, which means that you have no node after it. So the way we implement that in code would be something like, here's a list node, okay, which is gonna be head, well, the contents of head, and while this is non-null, what you do is free cur and then go cur next. Now, and of course you'd have to do something like deinitialize the contents of head, so set it to like no. But there is a problem with this code, and the problem is that we have a use after free. So there isn't really, I haven't thought of a different way of doing this other than just holding next into a local variable, then freeing current, and then setting current to next. Summon like this, basically. So this ought to do it. Yes, and there we go. The test does pass, so now we just need to check that our array is correct. Our list is correct, sorry. So let's create a contents array that contains basically 0. And for, let's make a size t because pedantic. And there we go. Who this? Oh my god, it's Shiro. I'm doing the streamy business. Yes, I am. Let me change my audio settings here to my headset. Okay, there we go. Okay. What up?
Not much. Just the usual stuff.
Ooh, just the usual stuff.
Yes.
Yes,
How about you?
yes. I'm doing pretty good.
What you working on right now?
I am making a linked list in C.
Sounds like fun.
It's not. I can advance this up here.
Fun stuff with the notes.
How have you been?
Okay, I guess. University and stuff, you know?
Oh, you have uni again? Huh? I thought you were done with that.
No, not yet. Still takes a bit.
So, we're gonna do an assertion here, like this. And hopefully this passes again, because I haven't changed anything. I've just added an extra check, and I get a segfold. Why do I get a segfold here? Probably the dereferencing. Okay. Oh, I also have another problem here. I need to free core data. There we go. But that's not it. This is something else.
How's Phyllis going, by the way?
I haven't worked on it in a while. It's basically done though. That's the thing. Like technically speaking, the project is done.
It's finished? No way.
Yeah, it's finished. Wanna take a look?
Let's see.
Why am I segging the folds?
You call this done?
Wait, why? Why is it not done? Tell me.
Is there any documentation at all?
There is documentation. You just need to generate the docs using a Gradle task.
Okay. But like not even a readme? Is there?
Readmes are overrated. No, there isn't. That's the thing.
Okay.
I was joking with it with a classmate of mine. But like,
Yeah.
I have this big project that is done, yet I don't even have a README for it.
God.
Aren't I just amazing?
Yeah.
Yes. Okay, let's Valgrind this and see what's happening here. Invalid read of size 4, line 17. Line 17. Okay, yep, as I expected, but what's wrong here?
Wait, since when are you modding?
Hmm?
Since when are you modding right now?
What do you mean I'm modding?
On Twitch you have the tags of Minecraft and mod.
Wait, what? Or do I?
Yes. Minecraft mod, modding, programming, Rust and Image. Basically only two of those apply actually.
Okay, let's no Rust, no modding, just C. There we go.
See what?
I don't know. Let's refresh this and there we go. Happy?
Happy.
Okay. So what's wrong about my stuff, man? It's probably a very obvious issue here. Item buff is one allocation, and I mem copy into it. Oh, okay, makes sense. Yeah, this should be. Let's make it like new node data is this, and then if not new node data, then we fail. Otherwise, we copy into new node data the contents of that. There we go. Okay, uninitialized pointers. Amazing stuff. Okay, so now we can insert at the beginning of the list. So let's also make it able to remove from the beginning of the list with a pop function. Cheryl, do you have any idea why linked lists are hated?
Because you have to do them in university usually.
I mean, you do, but like, I don't think that makes up for a reason to hate on linked lists. Personally, I don't like them, and the reason for it is because they basically are arrays but inferior.
Yeah, I guess kinda.
A lot of people say that they are like superior.
Dynamic arrays, kind of, right?
Well, yeah, of course, dynamic arrays, not static arrays. But well, the thing about a linked list is that if you wanna go to a node, firstly, you don't have random access, okay? which means you cannot say I want to go to node 4 and you just
Yes,
instantly jump there. You have to go through all nodes.
You have to iterate through that.
Which is a pointer in direction of n levels. So at worst, when accessing a linked list, you can do n pointer in directions. Which, in case you didn't know, memory lookups are really slow. Okay? Whereas with an array, you only have to do one lookup. So what is Pop gonna do? Pop is gonna basically get the basically do a mem copy into item out of dereference head. Item out of dereference dereference head, and this will give us a list node. A list node data, sorry, a list node pointer, and we're copying data item size data. I don't know. And now, of course, this could be a problem if the list is empty. So we need to make a check here if dereference head, if not dereference head, we need to return 0, which means we fail to extract an element. And otherwise we return 1, and we need to free the contents. No, we need to this node pointer. This is new head. It's gonna be head next. We need to free the head, not the head. We need to first free the data block that head holds, and then we need to free the contents of head. There we go, like this. And then we need to write into head the new head. There we go. Something like this ought to do it. So now if I go here, I should be able to say ll pop from L. What is? Okay. ll pop from L an element, and let's I out, I guess. I out size of int, and we need to assert that we can remove an element now. We also need to assert that I out is equal to I, and finally we are gonna do an empty list check here, because I shouldn't be able to extract a new element from the list if it's empty, and the number of bytes here doesn't matter. Something like this. Okay, yeah, this needs to be noted. There we go. Okay, so now we can remove from the beginning of the list. Perfect. Now, what else might you want to do in a list? Well, a thing that lists can do that arrays cannot do is that you can insert elements in the middle of them. Like with an array, if you had like a big array and you wanted to insert somewhere in the middle, say you have 1, 2, 3, 4, 5, 6, 7, 8, and say I want to insert 12 here after 4. this means that I have to move all elements after 4 one position to the left. Sorry. One position to the right, okay? And then I can put 12 in here, which is an O of n operation. Like, because at worst, we'll have to insert an element in the beginning, which means we need to move the whole array over. Now, the same is true about list. It's also O of n, but the reason it's O of n is because you first gotta get to the point where you wanna insert an item. So, with a list, have 1, 2, 3, 4. Say you want to insert 42 after 2. To do that, you'll have to first find 2 and then put 42 after it. But putting 42 after it is actually quite easy, because the only real thing you need to do is consider this sublist, push an element at the beginning of it, which is 12, and then set 2 to be that to have a next, which is that new element that you pushed. So with this we get 2 new ideas. We get the idea of finding the nth element in the list and inserting an element at the nth index, okay? How do we do this? Well, it's actually not that bad. First, ll get, which is just gonna get us the nth element of a list. And it's gonna give us a list node. No, actually I think it's gonna give us the item it contains. And I'm gonna tell you the reason for that. This is the index. The way you would do this is you just have a for loop, one of those fancy C for loops, where you go I equals 0, I less than... let's do j. Actually, let's rename this to idx. There we go. I less than idx. I blue blue. But here you also make the check that the fuck is happening? There we go. You also have the check that cur is not null, which means that you'll keep advancing the list, and then cur, it's gonna be cur next. So this will leave cur with the ith element after it's done. So if idx is I, it's gonna have head. If idx is 0, then it's just gonna have head because this loop never runs. If it's if idx is 1, then it's gonna have the first element or null. So we see that perhaps cur might be null, which is the case where we don't contain index idx, has less than idx plus 1 elements. The list, there we go. Otherwise we do a memcopy into item out, cur data item size. And notice that here we don't remove the item from the list. Okay? The item still remains in the list. We just give the person who asked us the contents of the node. And now, because we need to insert at the middle of the list, because remember, that's how we got here, okay? The way we will do that is ll insert at a linked list, which is our head, after index, we're gonna insert a new item. See why not having generics is annoying? Because I need to pass so many extra parameters. I need to pass item size everywhere. Okay, so now what we're gonna do is we're basically going to do the exact same thing we did above. Actually no. Let's make a new function here. That's basically going to give us a sublist after the nth element, okay? Because again, remember that to insert 12, we can basically treat this as a smaller list and push at the beginning of it, and then change the pointer to this. The way we do this is we create a new function, list pointer, which is ll sublist and it's basically going to do the exact same thing we did here. There we go. Except instead of mem copying stuff, we're gonna return car? No. I'm gonna return this. A linked list, which is a pointer. Good. There we go. So yeah, we don't even need this. We can just return car. And now get can be re-implemented using ll sublist. Okay? We can go give me a sublist of head at index, and this will just give us that. Of course, we need to check if not cur to return 0 here. Like this. And now ll insert becomes trivial. We just need to pass head here, pass index here, and now we got a new linked list, which is the sublist, and we ll push into that sublist item out, item size. If ll push fails, we need to fail as well. It's there, isn't it? Oh, it's not item out, it's item. No matching function. Oh, right, you need one of this. Okay. Now, here's something funny. If I want to insert at index 0 at a list, I need to decide whether that means after index 0 or at index 0. Shiro, do you have any idea what it should be?
Yeah, totally. I do.
No, I mean, like, if you have a function that inserts an element at an index into the list, okay?
Yeah.
Like, would you like your function to insert the element, like, make the node at the index your element, or add it after that node?
I think I would go with inserting at a specific element, not after it.
Okay, so if I go 0, it means the new
Basically,
0th
insert it
element.
and push everything after this to next index.
Yeah, so basically, if I say insert, for example, at 1 here, insert 1 at 1, it's gonna...
Then you push over the previous one index to the 2.
Yeah, you push 2 over here. You go like this. Okay. So this is the new index. Okay. So the way we would do this is actually quite simple, because we actually need the n-1th element. The reason for that is because we need to change its next pointer.
Yeah. That's...
And this means
in the nature of the data structure, but it's not that great, actually.
Well, no, I don't think it's bad. Of course, if index is 0, we need
it's the worst case possible, yeah.
We need to change something here. But for now, we'll just leave it like this. Okay? So instead of passing it into sublist, we're going to pass it into sublist next. Like this.
Okay, honest question. How many to-dos and fix-mes do you have in the code right now?
3.
Oh, that's actually pretty good,
yeah. And I think this is actually... Yeah, this is fixed.
And... Keep your code base clean, huh?
Huh?
You keep your code base clean, huh?
Make this return the old value in case of override. Yeah, I don't know about this. Anyway. Yeah, it's not fixed yet. So, okay, now we've added the new head, so we need to go at sublist and set next to be wait, this is wacky. This is gonna... No, we don't want to do this, actually. Yeah, we don't want to do this. Because... Yeah, that would change the contents of the sublist next, which we don't want it to. Right? Let me get a light in here. There we go. So, wait. So, basically, I currently have 1. I have 1. So I want to treat the next of 1 as a different sublist. As a different list. Like this. Can I instead do something like this and then pass new node here and then make sublist next be the new node? There we go, like this. There we go. I think this is it. Now, why is index 0 a problem? It's because we don't have a previous element, so we need to change the head of the list instead. And it's actually pretty easy to do that. You just go head. You actually just LL push at the head. Item size, like this. That was actually easier than I thought. I expected it to be way harder. Okay, so now it's time to attempt to make this list, to make another list actually. Let's like this. Okay, there we go. Okay. So now this list should have everything except let's print the contents of this list. Like this, yes. And give me a fancy dot here. There we go. Like this. I don't need that. Okay, we have it's not really visible. We have everything except 3 in here. From 0 to 99. Now, of course, the list is flipped because of how it's implemented, but that's no problem. We just need to consider the... If 0 is the 100th, it's the 99th index, then it's 98, 97, 96. So we need to insert at 97. Set I to 3. I size of int. There we go. So, and again, print. I guess I should abstract this. Print list. And I need to assert that this is true. And now we got 3 at the wrong index for some reason. Why did we get that? We have 99, 98, 97, 96. Yeah, the new index is 96, my bad. Yeah, because it wasn't 99 before. It was 98. So stupid. Okay. So that covers insertion and getting items from the list. And now to remove items from a random index.
From a random index.
Yeah?
Okay.
What do you mean? What do you mean, why? Well, fuck you mean?
Why would you need that?
It's a list, bro.
Okay, so just randomly delete something from there. Okay.
So we'll get a sublist, and I guess we just
Again,
again.
I think I get what you mean with. Okay, okay.
No. I mean, like at any index, you can
Yeah.
just remove the item. I don't know what you were thinking.
Yeah. No.
By the way, sublist maybe null. Just thought about that. Okay. I mean, that's actually quite easy. If sublist is null, it means we got out of the array, which of the list, which means we just zero. Right? Oh no. Because that wouldn't allow inserting at the final index. Yeah, I'll have to look into this. So this gives us a sublist. Of course, if index is 0, we free head data. No, I need to return that. Data. I need to free what head holds. Can I get a list node on the stack here? Indirection requires pointer operand. Right. Indirection requires pointer operand. List node T is invalid. Yeah, but like why? I can memcopy into it, but I don't wanna memcopy, I just wanna... I have no idea what happened there. There we go. And we just pop. No, we can't just pop here because of how pop works. We just need to sublist data. Yeah, and if not sublist, we just return 0. We just return null actually. And we return the data, and we need to sublist. Okay, this is actually quite complex. Let's see. So I get the whole list in this case if I try to remove 0. I don't want to remove 0. Let's say I have 3 nodes. Have 1, 2, 3. And I want to remove 2. This is at index 1. So I'm gonna get its previous node, which is 1. So I get the whole list in return. I get the whole list in return. And what I do is from the sublist, yeah, okay, now I got it, I think. So what you need to do is you need to set the sublist next to be sublist next. You need to skip 1, which means you also need to store the old head, which is sublist next. Of course, there is a chance that the old head does not exist. In which case, I think you can just go if old head, then just set it to this. Otherwise, you set it to null. And you can just return old head data, but you need to free the old head as well. So you'll have to store the data. And like this. There we go. I think this is works.
I'm trying to make a German pronunciation now.
My German is very good.
Yes, it is.
I know.
Totally.
I'm trying to sound as textbook German as possible.
I mean, in American textbooks.
America. I don't know, man. It's just the land of the free.
Surely. If you call us free, yeah, sure.
Huh?
Yeah.
Okay, 1 second. Someone's calling me here. Let's mute the stream. Okay, I'm back.
Welcome back.
I mean, you were hearing me, but the stream wasn't hearing me.
Yeah, true.
The stream is actually quite dead. There's like 2 viewers. Nobody has chatted since a while ago.
Skill issue.
Why are we still here? Perhaps it's actually a skill issue. See, the thing with me is that I don't actually promote myself that good.
Yes.
That well.
Just take a look at Willis, for example.
Yeah. Exactly. I don't promote myself that well.
Mm-hmm.
Let's free the data. And let's first dereference the data. Angry German typing.
No, I'm actually.
Actually.
No, I'm doing some art stuff right now. For a mod.
You're arting?
Yes.
Yeah, I love arting. Okay, so remove is now working. Okay, I think this is the basic things I'm gonna leave in it. So let's just turn this into a header only. And we can do generics another day. Because, I don't know, it's been a while since I started streaming here. It's been like an hour and 20 minutes.
Damn.
I've streamed for longer in the past, but I'm not really feeling it right now, so let's just finish this up and be good with it.
Sounds like a plan.
Now comes the boring part of copy-pasting definitions. Can I help? Can I bookmarks? Let's see how bookmarks work. The command MA. How do I how MA? Okay, let's see how this works, because I wanna. You can place 20 C marks. You can't see them. It's just a position that Vim remembers. You can do A? No way. Huh? Wait. Okay, I get it. Okay, that's good. That's actually pretty good. And you need backtick to remove, but I don't have backtick on my keyboard, so I guess it's staying like this. Tax 0. What is tax 0? Merge message? The fuck? Okay. Okay, let's have a mark here. Let's put mark B here. And B. So now if I go down here, tac B, yay, gives me back. That's good. Oh, this is actually so useful. Oh, thank God I decided to learn this. Here I'm so happy I learned the new Vim thing.
What did you do?
I learned Vim.
After how many years now?
A lot. I've been using Vim for quite a while. Like, I bet it's been like 2.5 years easily.
More than that, no?
Perhaps more, yeah. I mean, Fellis is 1 year old at this point.
Oh damn!
Nothing would surprise me.
No.
Nothing would surprise
Is
me.
it really 1 year old? That's it.
Huh?
And was the first commit?
It is. It is. The first commit was in March last year.
Let's see. Yeah. Actually, it's like, let's see. Yeah, it had this 1 year anniversary. I can't speak. It's Sunday.
Yeah, you're broken.
Yeah, but you're 1 year on Tuesday.
Yay. On Tuesday?
Mm-hmm.
Damn, like actually? The fuck?
Yeah. 18th March.
Wait. Goth. Bro, I searched Goth. I wanted GitHub.
Goth Hub, okay.
Goth Hub. Wait, how do you see this?
Just go to the first comment.
Yeah, how?
All the way on the bottom, or I guess.
Do I need to press next 500 times?
No, it's only 3 times, I think.
Okay.
Don't have that many.
No, oh, you mean on Tuesday it was my 1 year anniversary?
Yes.
Oh, I thought it would be.
No.
Okay.
It was.
Yay.
You missed it.
Happy birthday, fellas. The mod loader that everyone should care about, yet nobody actually cares about.
Yeah. No documentation.
Yeah, that's as if that's the problem. As if that's the problem. It's not that Fabric is single-handedly carrying all of the modding space. No.
Nah, actually, I think Neoforge is even bigger than Fabric still.
Actually?
Yeah.
Nice.
I think so, at least. I'm not sure. But yeah, LexForge is basically
it's
not really used anymore.
Yeah, makes sense.
Yeah.
Does it even have maintainers?
Maybe, I don't know.
What do you mean, maybe you don't know? You better know, young man.
You know, at this point, I don't even care about this anymore.
I wanna kill everyone.
Just do Fabric and that's it.
Just do Fellas and that's it.
Yeah, if there would be documentation, I would do it, I guess.
Bro, you want the documentation?
Nah, don't document me.
There is example mod.
It's not documentation, though.
What do you mean? What kind of documentation do you need?
Yes. Annotate every fucking method with Java docs.
I can't annotate every method. I have annotated the API methods.
Okay. Tja, if you would have put this in your README, I would have known, you know?
I'm gonna kill this whole fucking season.
No.
Wait, in which case does this return null? This will only return null if car is null. Yeah, so my logic here was correct. Interesting. One of the few times that I was actually smart. Yeah, the only case where it returns null is if I is greater than or equal to, or if the head is null, or the current node is null, which means we've run out of elements. So, in any case that it's if it's index out of bounds, then it's always null. Yeah. Everything works. I'm happy.
Nice.
That's okay. Scratch should not be in here. add initial linked list implementation. We'll add generics another time.
It's gonna be a problem for future Joe.
Huh?
It's gonna be a problem for future Joe.
We need to talk about your balls.
Okay.
These are my balls.
Sounds gay.
Have you seen the Manscaped ad?
There's so many now.
Huh?
And there are many.
Yeah, but now. I'm talking about the. We need to talk about your balls one.
Maybe, I don't know.
Photo by Youssef Espagnoli by Ansplas. Am I allowed to show this? I'm not allowed to show
this. I think so, yeah.
Am I?
Yeah. Unsplash is a platform with a lot of like free licensing stuff.
Oh, okay, good.
Not all of them, but most of them.
Yeah, those are nice pictures. Anyways, I stop streaming now.
Yes.
We've already picked at 2 viewers, which I guess is you and me.
Maybe.
Okay. I'm gonna say goodbye in case that other person is not you or me.
Yes. And for all the VOD watchers.
Yeah. Of course. Do I even have VODs on? I should have VODs on.
Let's see. Do you?
Well, let's see. Can you see that? How do you see that?
I check your videos tab. And there are...
There shouldn't be old ones.
Yeah, no. Doesn't look like it.
But I recall that it did record old ones. Did they delete the VODs after some time?
Yeah, after a long time. If you don't like save them as highlights or something.
Okay, yeah, makes sense. Then yeah, so VODs should be on because I remember it recording VODs in the past. So yeah, for any VOD watcher, I might actually post this on YouTube. I don't know how that's gonna go.
You go for it?
Yeah, I guess.
I think there's some export options on Twitch.
What?
Should be some export options on Twitch.
Yeah, I guess. And then I'll just shamelessly self-promote, just go into my classroom and like put my channel on the
projector. Look at me code for 2 hours on the C.
Yeah. I
mean, list structures, let's go.
Yeah. Like, get people interested, you know.
Surely.
Yeah, of course, because everyone wants to watch linked lists in 2025.
Yes. And just use Java. It's easier.
Yeah. Actually, just use HashMap.
Or that, I guess, yeah.
Yeah. It's amazing. Like, I saw a video where a guy was preparing for, like, coding interviews.
Yes. And you can throw hash maps at everything. Yeah. Or hash sets, I guess.
Yeah, and, like, the interviewer comes on, and he asks him, like, why do you want to work for our company? And he goes, hash map. I'll use a hash map.
Yeah.
What LeetCode does to a motherfucker.
I mean, it's true, isn't it?
Perhaps.
Alright.
I haven't done enough LeetCode for it to affect me.
That's good, yeah.
Anyways, I'm gonna leave everyone. Enjoy the rest of your day.